Alright, so the last video we reviewed some basic definitions and terminology. Next, we're going to continue with definitions and terminology a little bit, and just say that a rational expression for us is going to be the ratio of two polynomials. So remember, polynomials are, like ax plus b, and then you have cx squared plus dx plus e. I'm just making things up, but it's going to be something like each of these. Okay, and again, if you don't remember the exact definition of a polynomial, I'm going to tell you to go back to section 1.5 and just review that definition. In any case, here we are. The only limitation we have right here is that the denominator q cannot be 0, because otherwise we divide by 0 and, well, bad things happen. Okay. As we write this form actually assumes that we are in lowest terms, which we think of as simplified form. So the thing is that if there are any common factors, right, like there is c in this as a common factor to numerator and denominator, we would want to cancel those out. Again, assuming that the value of c and b are not 0. Okay, otherwise, again, you're canceling 0 and dividing by 0, so it's really kind of weird. Okay, so then we're just going to jump right in and do some quick examples. And one thing that we want to do as we progress along is kind of start to keep track of what we call restricted values. And these are values that produce an undefined result. Okay, so in essence, the values that would cause us to divide by 0. Okay, so we'll kind of go through how to find these in each of the problems that we work on. So here they are, and if you want, you can pause the video, try them out for yourself. Otherwise, I'm going to dive right in. Okay, so here we want to know if these are simplified. Well, at first glance, you're like, well, maybe they are simplified. And then, now I'm going to make mistakes intentionally. Do not do these. Okay, so students, when they see these, historically what they have done is they said, oh, there's an x squared in numerator and denominator. Oh, that's a common factor. I'm going to cancel it out. Oh, there's a 4. I'm going to cancel those out. So I'm left with negative 1 over 4x. Okay, this is wrong. Okay, the reason is that when we cancel these common factors, right, they have to have, if we look at this closely, they have to have multiplication in between them, not addition or subtraction. Okay, so there needs to be multiplication present between the two factors in the denominator and the numerator. So this is invalid. Okay, I understand the sentiment, but we can't do that. So what do we want to do? My favorite F word? Factor. Okay, actually that's my first favorite F word. The other one is FOIL. Okay, so here we go. We're going to factor this thing. X minus 2, and we're super good at factoring. X minus 2, X plus 2 in the numerator. And the denominator, again, you could use AC method, but this is also the same as a perfect square identity. So X plus 2, or X plus 2 squared. Okay, either way. And now in this form, I'm in this form where I do have the multiplication, right? And I see, oh, there is an X minus 2. Now in this form, when I have multiplication between these, I can cancel. Okay, and I should end up with the final result as x plus 2 and x minus 2 in the numerator and x plus 2 in the denominator. And that is really as far as I can go. Again, you cannot cancel the x's and you cannot cancel the 2's and say this is negative 1. That is a mistake. Okay, don't do that. Because again, what you're really doing is dividing, and you would have to, if you divide something by one thing, you have to divide everything by that same thing. So you'd have to, if you cancel the 2, divide everything by 2. Okay. Now I mentioned restricted values. Restricted values actually come into play in this original part here. It would be whatever produces 0 in the denominator. So really, it's the same as factoring, and then setting the denominator equal to 0. And so if we do that, I would find that x, okay, set the 0 product property again, so we'd have x plus 2 times x plus 2 is equal to 0, and then x is equal to negative 2 and negative 2. So this would be our restricted value, and all I'm going to do is to say that x is not equal to 2, okay, for our restricted value. Or So a restricted value is x is equal to -2, or you can just say that x cannot equal 2. So restricted value is x is equal to -2, -2, or equivalently, x is not equal, or x cannot equal -2. Same ideas, okay? The next one, here I want you to factor this, okay? So pause video and factor it on your own. And so I went ahead and factored this, and here it is. I'll just make the comment, or the statement here, that I did skip a little bit of work. So again, if you need to do more work, that's fine. Now at this point, before I cancel, this is when I should really state my restricted values, and that's anything that makes the denominator 0, any value of y that makes the denominator 0. So y is going to be -2, +3, and -3. Okay, or equivalently, you can also say that y cannot equal -2, 3, and -3. Okay, same ideas. Now, in terms of simplifying, I have a common factor of x plus, or y -2. Again, these are all multiplied. I need multiplication between things to cancel them. So, and then the y plus 3's cancel. So at the end of the day, I'm left with 4y in the numerator. Denominator, I have 3y -3. Okay, and if you want to distribute the 3, well, you're welcome to. Okay, so that's the idea here, and we are just going to continue to use this over and over and over in our work.